Hello my dear students of class 12. Today I am going to tell you about the application of Gauss theorem. The first one is we want to calculate electrical intensity at any point due to if shape of conductor is spherical, it is solid. You are giving plus q charge to this solid sphere whose center is O and radius is capital R. The moment when you will give this plus q charge to this solid conducting sphere, the charge will uniformly resist along its whole volume in this way. We want to measure electrical intensity at 3 points. One point A is outside. At this point we want to measure. At this point we want to measure B, and somewhere inside at point C we want to measure. Let O to A distance is x, O to C distance is smaller. So now let's start one by one. Number first, at C. So to calculate intensity, first of all, draw a Gaussian surface. This is Gaussian surface. At this point, intensity direction will be outward because test charge is there outward, and direction of area vector will also be here. That means theta is 0 degree. Apply Gauss theorem. Close surface integral vector E dot vector ds is total charge occupied on epsilon. Remember that here the total charge is only this much surface, this much. That assume q dash upon epsilon naught. When you will put here theta is 0 and when you will solve this integration, you will get E into ds is the surface area of this much only after integration 4 pi r square q dash. Now question is what is q dash? For q dash, because here charge is distributed uniformly along its volume, so here volume charge density will come, and volume charge density is q dash upon v. So therefore q dash will be density into volume, means density into 4 upon 3 pi r cube. So you can write here rho into 4 upon 3 pi r cube. In this way you can break. Now question is what is the value of this density for whole surface? Now again, since density is total charge on volume, q will be as it is. Now volume for whole surface will be 4 upon 3 pi capital R cube. In this way you can write here E into 4 pi small r square will equals to, in place of rho you will write q upon 4 upon 3 pi capital R cube into, here you will write 4 upon 3 pi small r cube divided by epsilon naught. Now solve this will cancel out and r square will be only 1 here. Now E will be what? Q upon 4 pi will come this side, epsilon naught into 1 r will left here and this r cube will left here. What you will find? This is at C. You will find that intensity at C proportional R. This is inside. Now, secondly, if you want to calculate at surface means B. You have assumed here B. So already it is enclosed. Already it is enclosed. Vector E dot vector ds enclosed surface integral is total charge upon epsilon naught. Here total charge is q divided by epsilon naught because here whole surface is there. You put here intensity direction is this, area vector is this, that means theta is 0 degree. Then you will put all these values, you will get E into 4 pi capital R square is q. As you change here in the form of density, you can change here also, but no need to change here. You can write q upon epsilon naught. So E will be what? 1 upon 4 pi epsilon naught into q upon r square. This shows intensity at B proportional 1 by r square. Okay. Now for outside, it is at A. Third one is at A, that is outside. Outside first of all, draw Gaussian surface. Now this is Gaussian surface. Here is hypothetical test charge. Intensity direction will be this. Area vector will be this. Theta gives 0. Now apply here Gauss theorem. Close integral vector E dot vector ds is total charge upon epsilon naught. This whole surface occupies this much charge only. That is why here also q upon epsilon naught. When you put value of theta in this place and when you will solve it, you will get E into 4 pi x square. Q upon epsilon naught. So E at A, you will get Q upon 4 pi epsilon naught into 1 by x square. Means intensity at A will be proportional to the 1 upon x square. So this is for outside, this is at surface, and this is inside. So if you draw a graph between intensity and distance, so suppose that on x-axis you have taken distance and on y-axis you have taken intensity. Now this is origin, that is 0. You will get graph in this way. Intensity will increase inside till this point. Means here this becomes small r, which is equals to capital R. Means here you are getting intensity proportional small r. This is inside. After that, either you choose this one or you choose this one. Means either at the surface, you are going at the surface, and after that you are going outside, intensity decreases. This is the intensity and distance graph for this particular application. Here distance is more than capital R. For this much portion, distance is less than capital R. And here exactly distance is R. Means at this point you will get intensity maximum. In this way you can plot the graph between intensity and distance for this particular application. Okay. Now the second application is same like first one, but here that conductor of a spherical shape is hollow. Means this is a conductor which is hollow. You are giving plus q charge. Center is O, radius is capital R. Now the moment when you will give plus q charge, because it is hollow, all the charges will align on the outer surface of this particular conductor in this way. Now here also you want to measure intensity at A, intensity at B, and intensity at C. For example, at C you want to calculate. For that, draw Gaussian surface. This is Gaussian surface whose radius is small r. Apply Gauss theorem. Close integral E ds total charge upon epsilon naught. You can see this Gaussian surface carries 0 charge. There is no charge present inside this. So since total charge is 0, therefore intensity at C will be also 0. Okay. Now second, at B, at this point. So as you have done in the first application of Gauss theorem, same process you will start, and you will get here intensity at B proportional 1 by r square. Same process. How? Intensity direction will be this, area vector will be this, theta is here 0 degree. Now when you will put all this value and solve the intensity, you will get this result. And similarly at C when you will solve, not C, in fact A, outside, draw Gaussian surface. This radius is capital X, intensity direction is this, area vector is this, theta is 0 degree. Put all these values, you will get here again same result, intensity at A proportional 1 by x square. So this is for outside, this is for surface, this is for inside. Now here if you draw graph, this is distance and this is intensity, you will get this type of graph. Because when the distance is exactly r, you are getting intensity. When distance is less than r, intensity is 0. You can see here, and here distance is more than r. then intensity decreases. Means at this point you will get maximum intensity. So this is the graph for this conducting hollow sphere between the intensity and distance. Okay. Now third application is, there is a infinitely large thin wire. This dotted line indicates ends are not clear from where this wire starts and from where this wire ends. In this infinitely large, I have given plus Q charge to this wire, and that charge is uniformly distributed over the surface of the wire in this way. In this infinitely large wire, I have taken this much section of the wire mm. Let the length of the wire is L, and we want to measure intensity somewhere at this point, which is at distance R. If we want to measure intensity at any point, we should draw Gaussian surface. For Gaussian surface, assume number of points this side, number of points this side. In the same way, here also distances are number of points this side, number of points this side. And when you draw the locus of all such points, you will get a Gaussian surface in the form of cylinder. A cylinder whose radius is R and length is L. Now here you can observe, for this point intensity direction is this, and if we assume area vector, a small area patch, that is here. Here also intensity is this, area vector direction is this. For here also intensity is this, but for this small patch area vector direction will be this. Here also direction of intensity will be this, but for a small area patch area vector direction is this. That means here angle is 90 degree, angle is 90 degree, angle is 0 degree, angle is 0 degree. Angle means between intensity and area vector. Means that whatever the total amount of flux will be here, that is because of two surfaces, curved surface and this is flat surface. Flux for the flat surface is 0. Why? Because angle is 90 degree. That's why the flux at the flat surface will be 0. Means total flux you will get only due to curved surface. Means apply Gauss theorem. Vector E dot vector radius, total charge occupied upon epsilon naught. When you put the value of vector E dot vector ds, that is E ds cos theta, theta you will write 0, intensity is constant, it will come outside, intensity will be here, only ds will left here, total charge upon epsilon. Now intensity into area, this integration 2 pi r is total charge upon epsilon. Now the question is, what is total charge? Because here distribution of charge is linearly, that means here you will get linear charge density. Linear charge density means total charge upon length, that is L. So total charge will be what? Lambda L. So here you can say lambda L upon epsilon naught E into 2 pi r L. You solve this, you will get lambda upon 2 pi epsilon naught into 1 by r. Means intensity proportional 1 by r for this particular shape. So this is the formula of intensity if there is a wire of infinite length and uniform charge distribution is present there. Okay. Now this is the fourth application. In this application there is a thin sheet. This is a thin sheet of infinite length. Means it is not clear up to which height it is here and up to which height it is here. That is why I have mentioned here curved portion. And it is uniformly charged. Suppose plus Q charge is given. So this is uniformly charged. In this way, it is uniformly charged. Okay. You want to measure intensity due to this arrangement somewhere at this point. Suppose at point T. Because it is thin and it is uniformly charged, so two sides will be acted here. That is why at the same distance here also a point will be Q. If you take it, this distance is R. then this distance will also be r. Now, if you want to calculate intensity, you should draw Gaussian surface. So there are number of points here which are at the same distance r. Here also number of points which are at the same distance r. So if you draw Gaussian surface, you will get a cylinder in this. Okay, this is the cross section which is inserted in this particular sheet. Now apply Gauss theorem. Here intensity direction will be this, and if we assume a small area vector, then area vector direction will be this, means theta is 0. For here also direction of intensity will be this, area vector will be this, theta is 0, means this is direction of intensity, and for this area vector is here. For this portion area vector is here, intensity direction is this, means theta is here 90 degree, theta is for this section is also 90 degree. Means total amount of flux here also, flux due to that curved surface and flat surface. Flat plus curved. Flat plus curved means what? For the curved surface, total flux will be 0. Why? Because theta is 90. So whatever the flux you will get, that is because of flat surface. So Gauss theorem, vector E dot vector ds, and because here two surfaces of this particular sheet is having, so we are mentioning here twice, is total charge upon epsilon naught. Now 2E, when you integrate this, it will come as total charge upon epsilon naught. Because distribution of charge is here along the surface, so surface charge density will come here, sigma is upon epsilon naught, 2Es. S and S will cancel out, intensity will be sigma upon 2 epsilon naught. So with the help of this formula, you can calculate intensity at any point due to uniformly charged thin plane sheet of infinitely large. Okay. Now this is one more. If sheet is there, but it is not infinitely large, thin plane, but there is a pair, means two sheets are there. Okay. Now if this type of sheet is present, both are having, suppose that same surface charge density of positive charge. Remember this, same surface charge density of positive charge, means whatever the surface charge density for here, same is for here, and both are positive charge. Okay. Now here you are getting three regions. This is region first, this is in between the plate, and this is region third. If one time you will keep test charge here, then its intensity direction for this test charge will be this side E1, and for this also this side, that is E2. If you are putting that test charge here somewhere, then for this intensity direction will be this, and for this intensity direction will be this, for this particular test charge. If test charge is present here in the region third, for this intensity direction will be this, and for this sheet also intensity direction will be here. Now you can calculate intensity for all the three regions. For first region, net intensity E will be, because intensity is vector quantity, so it will add. Now you have already solved intensity to plane sheet. For one plane sheet, sigma upon 2 epsilon naught, then for other also sigma upon 2 epsilon naught, you will get result sigma upon epsilon naught intensity at region first. For region second, here net intensity will be E1 minus E2, that will be 0, means there will be no intensity in between the charge plane sheets if they are of same nature and same surface charge density is present. For third region, from the figure it is clear, in the same direction, so you can add, you will get same result, sigma upon epsilon naught. In this way, if the same nature charge plane sheets are there, you can calculate intensity in three different regions. Suppose that one is of positive density and other is of negative surface charge density, means here positive charge, here is negative charge, but strength is same. Then 3 points again you can consider. This is region first, region second, region third. For region first, if you keep test charge somewhere here, so for this intensity direction will be this, but for this it will be inwards, because test charge means hypothetical positive charge will be attracted towards this negative charge. For here outward, that is E1, and for this negative also it will attract inward E2. For here, for this positive charge outward and for this negative charge inward. This is E2. So for region first, intensity will be E1 minus E2, that is 0. You can see both are in opposite direction. For region second, intensity same direction is there, then you can add. So this will come sigma upon epsilon naught. And for the third region, for region third, intensity at third region, then you will see. So that will be what? E1 minus E2, that is 0. In this way, you can calculate what is the intensity of charges, intensity produces by the plane sheets, pair of plane sheets at three different regions. In this way, for same charge distribution of same nature, for opposite charge distribution of opposite nature. Okay, all the best. God bless you.